Hi guys, welcome to yet another tutorial. On this video, I am going to show you how to build an Excel program for the determination of standard Proctor test. I am going to cover how to get the maximum dry unit weight of compaction and optimum moisture content. Also, the calculation and plotting of the dry unit weight versus moisture content for degree of saturation. So here we have this standard Proctor test data. First, we have the volume of the mold. Next, the weight of moist soils in the mold and the moisture content. So this is just an example. You can change it to whatever values that is needed. And also we have the degree of saturation. So I just labeled it S1, S2, and S3. Lastly, we have the specific gravity. So here we have 2.7. For the first step, we have to get the values for moist unit weight and dry unit weight. So basically, I just copied this table here and then made another table for the moist unit weight and then moisture content. Just copied it here and another table for the dry unit weight. This way, it's much easier to solve for this too, because in order to get the moist unit weight, the values needed are the volume of mold and weight of moist soils in the mold. And for the dry unit weight, we need the moist unit weight and the moisture content. So here we have this formula. For the moist unit weight, we have weight over volume of mold. So the weight here is this one, the weight of moist soils in the mold. So you just have to divide the weight over the volume. And for the dry unit weight, that's basically moist unit weight over 1 plus small letter W, which represents the moisture content. So that don't get confused with the big letter W and the small letter W. Now moving on, for the moist unit weight, for example, here, I just divided the value for the weight of the moist soils and the volume of the mold. So that gave me the answer of 113.4. So I just have to follow this formula for the rest of the table. Now for the dry unit weight, again, the formula is this. Example, this is what I used. I just divided the moist unit weight with 1 plus the moisture content. And don't forget to divide this by 100. So entering this formula, I got 103.1. For the step 2, we are going to plot the moist unit weight versus the moisture content. So this is what I initially made. And I'm going to make another one just like this. So first, what we have to do is click Insert, then XY Scatter, then Scatter with smooth lines and markers. Now let's right-click, then select Data. Now click Add. Then for the X values, we are going to use the moisture content. For the Y values, we are going to use the dry unit weight. Just highlight that, then okay. So this is how it looks like. So the next step is to format the axis. So I just have to click this X values, then right click and find Format Axis. And for the minimum bounds, I used 8.0. And for the maximum, I used 20. For the units, for the major units, I used 1. And for the minor, also 1. So we're done with the X values. Now let's format the Y values. Just click the Y values and For the x values, I used 90 for the minimum bounds, then 140 for the maximum bounds. And for the major and minor units, I used 10:1. Okay, and you can also add axis titles. So let's put here dry unit density, and here moisture content. Now that we're done formatting the x and y axis, the next step in plotting is to add minor grid lines. So in order to do that, let's click this x values, then right click, then find add minor grid lines. And after that, right click again on the x-axis, then format minor grid lines. And as you can see here, we have to change the color for the minor grid lines. You can choose whatever color you like. For the major grid lines, let's also change the color. Now for the y values, let's right click again, then find add minor grid lines. As you can see here, there are small lines in between these major grid lines. So let's right click that, then format minor grid lines. So you can change the color again here. Let's choose orange. Then for the major grid lines, let's choose another color. There you go. Okay, so now that we have graphed the curve, let's see where the optimum moisture content is and the maximum dry unit weight. So as you can see, for the max, it's actually here. So let's put an indicator that this is where the optimum moisture content and maximum dry unit weight is. So first is have to again select data, then add, and for the x values, this is for the maximum dry unit weight. So you can also make something like this. For the x values, this is what I'm going to use. For the y values, so this is like a coordinate x and y values. So since I want to make a line like this, obviously the x values is from 0 to 14, and for the y values from let's say from 8 to 14, the y values is the same, which is 108.9. So it's exactly at 108.9. Now for the optimum moisture content, you just have to do the same. Right click on the graph, right click, then select data, then add, and for the x values, that's 14 and 14, and for the y values, that's 0 and 108. Click OK. So this is how it looks like. There's a line here and also a line here. So we can put the end arrow. So for example, this one, there you go. So this arrow over here indicates the maximum dry unit weight, while this vertical arrow here indicates the optimum moisture content. So that's it. That's how you graph a dry unit weight versus moisture content. So for 1A, which is get the maximum dry unit weight of compaction and optimum moisture content, the final answer is 108.9, and the optimum moisture content is 14. So in here, for example, if I change the values here, the correct answer, the correct values here and here will change, and also the graph. So for example, let's change this to 4. Doing that, so values changed and the curve also changed. Now let's proceed to step 3, which is calculate the dry unit weight versus moisture content for the given degree of saturation. So yeah, we have this given, the specific gravity, which is 2.7. And for the moisture content, it's already also given. So here, basically, you just have to follow this formula for dry unit weight given specific gravity and the moisture content and degree of saturation. Also, we have to take note that the unit weight of water here is 62.43. So here, for example, this is what I used. I already multiplied this to 62.43. So I used this as a constant. And as you notice here, the 68, that's the value for the moisture content. So I divided that into 100. And also the degree of saturation, which is given here. For the S1, that's 80%. So I also divided that into 100. Now entering this formula, I got 126.03. And here, basically, just have to use the same formula for S1, S2, and S3. The only thing that you have to change here is the value for the S. So at S1, you will have to use 80%. So don't forget to divide that into 100. And for the S2, I used 90. And for S3, I changed the S here to 100. Divide by 100, so that's 1. Here, feel free to pause the video and take note of the formulas. In calculating all of these values, we got the final answer. So I just copied all of this here. So this is the final answer for 1B. Now for the last step, which is to plot the dry unit weight versus moisture content for the degree of saturation. So as you can see here, there's 3 curves. This one's the S1, the 80%. This one's the 90%, and this is the 100%. So for plotting here, I prefer to retype all the values for the moisture content, the dry unit weight at S1, S2, and S3. So here, let's make another graph just like this. So you can just copy this, the one that you made at 1A, and then just plot the curve above. So let's copy this one and paste. Here you have to right click here anywhere in this graph. Right click, then find select data, then add. And for the X values, you'll need to use the moisture content, and for the Y values, let's use the S1. Click OK. This is the S1 for the 80% degree of saturation. Now let's click select data again and add another series. So for the X values, let's use the moisture content. And for the Y values, this time we are going to use the S2. And click OK. As you can see here, this is how it looks like. And again, select data, then add. For the X values, moisture content, and for the Y values, we're going to use S3. So continue, OK. So this is how it looks like. Okay, so that's it for this tutorial. If you find this video interesting, again, feel free to pause any part of this video and take notes of the formulas. That's it, and thank you for watching.